In April 2029, an asteroid the size of a skyscraper will pass closer to Earth than our own communication satellites. When scientists first calculated its path, they declared a record-breaking collision threat, the highest ever recorded for any object of its size. But here's what most people don't realize. The object we found, tracked, and fully calculated isn't actually the most dangerous part of 2029. Something worse is still out there, completely invisible to our telescopes, hiding in plain sight this entire time. And by the end of this video, you'll understand exactly why that should concern you more than the asteroid everyone's already talking about.
Apophis is a stony asteroid, roughly 340 meters wide, about the length of 3 football fields laid end to end. It's a dense, rocky body, the kind of object capable of carving out a crater over a kilometer wide on direct impact. It was named after the ancient Egyptian god of chaos and destruction, and that name wasn't chosen lightly. Within just a few months of its discovery, astronomers realized this particular asteroid could become a genuine, calculable threat to Earth. Not some distant hypothetical, but a real object on a real collision course that needed to be tracked immediately.
June 2004. Astronomers at the Kitt Peak Observatory in Arizona spot a faint point of light moving along an unusual path across the night sky. At first, nothing about it stands out. Just another routine discovery among thousands of similar objects cataloged every year. But when researchers run the calculations forward, projecting its orbit years into the future, the result stops them cold. In 2029, this object's trajectory would bring it dangerously close to Earth's own orbital path. What started as an ordinary night of observation had just uncovered something that would dominate headlines for the next several years. December 2004. Refined calculations put the odds of collision at 1 in 37, an alarmingly high probability by astronomical standards, where risks are usually measured in millions to 1. NASA and the European Space Agency issue an official warning. News outlets around the world pick up the story almost overnight, running headlines about a real doomsday asteroid. This wasn't abstract fear. An object the size of Apophis, striking Earth directly, could level an area the size of a major metropolitan city, releasing energy equivalent to thousands of nuclear weapons. For the first time in decades, the world was watching a genuine, mathematically calculated threat unfold in real time. Asteroid danger is measured using something called the Torino Scale, rated from 0 to 10, similar in concept to the Richter scale for earthquakes. In December 2004, Apophis was assigned a rating of 4, an absolute record at the time, higher than any other object had ever reached in the history of tracked observations. A rating of 4 means worthy of attention from astronomers, a close encounter meriting concern, though collision remains unlikely. For the first time, the public was witnessing a real, mathematically calculated threat from space, playing out with actual numbers instead of vague speculation.
Throughout 2005 and 2006, astronomers gathered new data and narrowed down Apophis's trajectory to within a fraction of a percent. The probability of a 2029 collision dropped to essentially 0, and the object was downgraded to a 0 on the Torino scale. Officially, the threat was closed. But fully clearing that risk for 2029 specifically took scientists nearly a decade of continuous analysis. And somewhere in that decade of careful observation, something else caught their attention. Something that had nothing to do with Apophis at all, but that would turn out to matter just as much. We'll get to that.
Even without any risk of collision, the encounter itself remains extreme. Apophis's orbit crosses Earth's path almost tangentially, and in 2029 specifically, both trajectories align with precision down to a fraction of an hour. This kind of alignment between a large asteroid and our planet's orbit doesn't happen often. Astronomers estimate an event like this occurs perhaps once every few thousand years. This isn't a coincidence or a near miss caused by chance. It's a rare geometric convergence of 2 separate orbital periods, one that scientists have been able to track and predict with remarkable precision for decades in advance.
April 13th, 2029,
At approximately 21:46 Greenwich Mean Time, Apophis will pass roughly 32,000 kilometers above Earth's surface. That's closer than the satellites sitting in geostationary orbit right now, the ones beaming down your GPS signal and television broadcasts. For comparison, the moon sits nearly 12 times farther away than that. The entire event, from the moment Apophis enters visible range to its closest approach and eventual departure, will unfold over just a few hours. And unlike most close encounters with space objects, this one will happen in plain sight, watched in real time by millions of people around the world.
At the moment of closest approach, Apophis will be visible to the naked eye for billions of people across Europe, Africa, and Asia. An extraordinarily rare event for an object of this size. It will move across the sky like a slow drifting star, crossing entire constellations over the span of just a few hours, visible to anyone simply looking up. No telescope required. For most people watching, this will be the only opportunity in their entire lifetime to see an asteroid of this scale with their own eyes, drifting silently overhead as a genuine piece of the solar system passes by.
Earth won't just let Apophis pass by unaffected. Our planet's gravity will slightly distort the shape of its orbit, alter its rotation speed, and could even trigger what scientists call asteroid quakes, shifts in surface rock caused by intense tidal forces. After 2029, Apophis will essentially become a different object, a new orbital path, a different rotation rate, and an altered future trajectory. What we're about to witness isn't just a close flyby. It's the exact moment a planet reaches out and physically reshapes a piece of solar system debris, live, in real time, for the world to see.
NASA repurposed the OSIRIS-REx spacecraft, the same probe that successfully delivered samples from the asteroid Bennu back to Earth, specifically to meet Apophis right after its close encounter with our planet. The mission was renamed OSIRIS-APEX. This marks the first time in history humanity will be able to observe an asteroid before, during, and immediately after an extreme gravitational interaction with a planet. A unique natural experiment that simply can't be recreated artificially in any lab or simulation. We're not just watching a flyby happen, we're sending a spacecraft to witness the aftermath firsthand.
The probe will measure exactly how Apophis's shape changed, how its rotation shifted, and what its surface composition looks like after being reshaped by Earth's gravity. This data directly feeds into planetary defense research. Understanding how large objects react to close planetary encounters helps scientists more accurately predict the behavior of other potentially hazardous asteroids we haven't studied up close yet. This isn't just scientific curiosity for its own sake. It's a real-world training exercise on an actual celestial object, giving us practical experience we'd otherwise only be able to guess at through simulations, ahead of any possible future threat.
Now, remember that detail from earlier, the one that came up during those years of careful analysis. While the entire world was watching Apophis, astronomers discovered something else entirely. Hidden near Venus's orbit lies an entire swarm of asteroids we can barely see at all. Sunlight from that direction makes observation from Earth extraordinarily difficult. These are city killer class objects, and we don't know the precise trajectories of most of them. We tracked Apophis 25 years into the future with total confidence. These ones, we can't say the same. If this caught your attention, subscribe, because it's about to get a lot more interesting.
Finding asteroids near Venus is nearly impossible from Earth. They hide within the sun's blinding glare, and observations are only possible during narrow windows around twilight, when the sky is dark enough but the sun hasn't fully set. New observatories, like DCAM in Chile, are specifically hunting this difficult region of the sky. Scientists are also developing space-based infrared telescopes capable of detecting dark, non-reflective objects that visible light simply can't pick up. But for now, this remains a race conducted mostly in the dark, searching for objects that are, by their very nature, almost impossible to see.
In 2022, the DART mission deliberately crashed a spacecraft directly into the asteroid Dimorphos, and it noticeably altered its orbit, the first successful test in history of an asteroid deflection technology. That means if a real threat is ever discovered, humanity already has a working method of defense. The question isn't whether we're capable of protecting ourselves anymore. The real question is whether we'll detect the threat in time to actually use it. The same way that swarm near Venus went unnoticed for years before anyone even realized it was there in the first place.
April 13th, 2029 will be a day when the sky itself reminds us just how small Earth really is on a cosmic scale, and just how fragile our understanding of what surrounds us truly remains. Apophis we've tamed. We calculated it, studied it, and we're preparing to meet it with a spacecraft the moment it passes. But nearby, invisible for now, others are still waiting their turn to be found. The search continues. Subscribe so you don't miss the moment we finally find the next one.